Okay, I'm going to do some quick work with properties of quadratics. So let me go ahead and get started with that. I figured I'd start with this vertex form because it's something that you should be familiar with based on function transformations. So this is called vertex form because that h and k right here serves as your vertex as well. And what I mean by vertex is when I'm drawing a parabola, the vertex is the point in which it's changing directions. So, or it's the maximum or minimum point. In this case, it's a minimum. If it's going this way, then it would be the maximum right there. Okay, so that's your vertex. So in this case, my vertex is going to be right 5 up 2. So it's going to just simply be 5, 5, 2. Let's see. Just like in this case, this one would be 3, 6. So we'll get there in a second. But again, it's right 3 up 6 is how the function would transform or translate itself. So that's the vertex as well. What else? Let's go ahead and put a dot where the vertex is. Now let's see if we can conclude really quick. The next question is direction. So which way is this thing going to be opening? So when you look at this, you should know based on those transformations as well that the A out in front is positive. It's not negative. When it's negative, it's upside down. When it's positive, it's right side up. So if you look out in the front of here, this is positive. It's just a positive 1 right out in front. So that means the direction is going to be, and instead of just saying up, we say concave. It's going to be concave up. And if it's concave up, like this picture that you see right here, concave up, then you're going to have a minimum point. There is no maximum because this is going to keep going up forever. No maximum, but in this case there is a minimum point. So we already talked about the vertex. That was at 5, 2. Now the axis of symmetry. The axis of symmetry passes through the vertex. If you think about a parabola, when it gets cut in half like this one, ideally, it would go right through the vertex, your axis of symmetry. So right here, there is your axis of symmetry. So the axis of symmetry is this vertical line right here. Passes right through the vertex. So truly, we're just using whatever x equals right here. And that is the equation of your line, x equals 5. So there's my axis of symmetry. What other questions do we have? We have roots, and we have describe the transformations. Well, let's look back up at the top. Now, you guys should be able to do this, but let's go ahead and talk about it anyway. So that h, while it's a negative 5, you would think it moves left 5, but it actually moves right 5. So it moves right 5. It has a horizontal shift right 5 and a vertical shift up 2. So I'm going to write those down here. Horizontal shift right 5 and vertically shifts up 2. Remember, that was pretty much the same way we got our vertex. We just look at the h and the k. So the h means it goes right 5, k means it goes up 2. So right 5, up 2. Now at this point, there's nothing else that you can really conclude. Vertex form doesn't help you get the roots. And what roots are is when this function, let's look right here, when this function is being graphed, the roots are the location at which it hits the x-axis. Okay? If it hits the x-axis. So right here, let's go ahead and graph this function really quick. I'm going to turn my calculator on. Gonna clear this out. Alright, so I should have x minus 5 squared plus 2. Gonna graph that. In this case, it doesn't look like it's gonna have any actual roots. It does, but they're imaginary roots. So I'll explain what that means a little bit later on in this unit. Maybe I'll explain it briefly real quick here. But I want to look at this table. Let's get some values down. So my vertex was at 5, 2. So I want to come over here to 5, 2. and I want to get 2 points above it and 2 points below it, so I'm going to get 4, 3, and 3, 6. And because I have those 2 points, then I don't really need anything else. I know that parabolas are symmetrical about their vertex, and that's the vertex, which means that this is going to be 3 also, and that's going to be 6. So 3, 4, 5, 6, 7. Yep, okay. So 4, 3, 6, 3, 7, 6, or 6, 6. Nope, 7, 6. Alright, there we go. So the parabola looks something like this. Now, when you don't see any roots, when you don't see a place where this function goes down and hits the x-axis, then the roots are imaginary. And we'll learn more of what that means when we get into the quadratic formula here in a few days. So I'm going to do this next one a lot quicker. So I want you to see how really easy this is. So right here, the h and the k tell me where my vertex is again. Right 3, up 6. So there's my vertex. Right 3, up 6. Here's my vertex. The direction, well, because there's a negative in the front, the direction is going to be downward. So that's going to be concave down. And because it's concave down, just like you see here, that means I'm going to have a maximum point. There's going to be a highest point. So I'm going to have a maximum value. Again, we already answered vertex. The axis symmetry passes through that vertex, so it's just x equals 3. It's the equation of that line, that vertical line that passes through the vertex. Zeros, notice over here it called them roots. Right here it's calling them zeros. No difference, okay? So it's 2 different ways of saying the same thing. As a matter of fact, on the back side, you've got x-intercepts and solutions. 4 different ways of saying the exact same thing. Where does that quadratic intersect the x-axis is the main point right there. So as far as the transformations are concerned, I'm going to look up here. So we're going to say it shifts horizontally right 3, vertically up 6. It reflects over the x-axis because of that negative, so that means it's going to be facing down. And it's stretched by a factor of 3/2. So I'm just going to shorthand a lot of that stuff, but I'll say right 3, up 6, reflect x-axis, and stretch by factor of 3. Now, as far as the rest of graphing this thing and finding the zeros, I actually have to plug it into the calculator. So, let's get out of the table, clear this out. Alright, so I'm going to have negative 3/2. I'm going to have x minus 3 squared plus 6. Graph that. Again, there's my roots, but let's just look at the table real quick. So the table, there's one of my roots. I can see it's 0. There's my vertex, 3, 6, so that's all I really need. 4.5, 0, which means this is going to be 4.5 and 0 as well. And this is going to be 2, 1, and 1, 2, 3, 4, 5. So 2 and 4.5. And not to be perfect, I'm just going to go ahead and estimate where this thing is going down to. Something like that. So my roots are, this is important. You can see your roots looking at the table sometimes. If y equals 0, then that's a root. Because when this function crosses the x-axis, y is 0. So my roots are at 1, 0. And 5, 0. So those are the locations of my roots, 1, 0 and 5, 0. And that's it. All right, so that's it for vertex form. That helped us get the vertex. Now we're going on to intercept form. So, of course, in the name, just like vertex form helped you find the vertex, intercept form is going to help you find the intercepts, or where the function actually crosses the x-axis, the roots, the zeros, the intercepts, the solutions, whatever you want to call it. So the way it does that is by setting this equal to 0. So I'm going to take each one of these factors that has an x in it, and I'm going to set it equal to 0. So let's go ahead and set negative x equal to 0 and solve for x. And when we do that, divided by negative, and 0 divided by negative 1 is going to be 0. So that function is going to cross at x equals 0, which is right here. So right there. And that function is also going to cross at, let's set that other factor equal to 0. I'm going to add 4 to each side. Notice now I'm using just that part. So the first time I used the negative x, set it equal to 0. Now I'm using x minus 4. I'm going to set that equal to 0. X equals positive 4. That's the other point at which it's crossing the x-axis. The direction in which it's opening, again, you can see that by the negative out in the front. So here, let me go ahead and approach this a little bit of a different way. I'm going to get rid of this table, and I'm actually going to graph this thing again before I actually answer all these questions, so you can actually see what I'm visualizing. So I've got, and something weird with these TI Inspires is when you type this equation in, you cannot type it in like this, negative x minus 4. It's not going to let me do this, so I'm going to press enter just to show you. So it says cannot accept change, invalid input. So for whatever reason, if I put a negative x and then times x minus 4 there, then it graphs it. Makes no sense to me, but that's how it is working nonetheless. Anyway, the reason I knew that this was opening downward was because of that negative. So it's going to be concave down. And obviously, you can answer these questions by just typing it into the calculator and saying, oh, it's facing downward, which means it has a maximum. You can do that. I'm just showing you how to do it without the calculator at first. The vertex, well, that's actually kind of tricky sometimes. So I'm going to show you how to do it without the table at first, because sometimes you can't find the vertex on the table. So you go to Menu, Analyze Graph. We know that it's a maximum. So you just use this thing and you highlight the vertex. So right there, I'm going to click. Then I'm going to drag it over the vertex. And click again. And then it tells me the vertex is at 2, 4. 2, 4 is where my vertex is located. I'm going to go ahead and write that down here. The axis of symmetry, well, here's the deal. Without even having that vertex, because of these zeros that I solved for a second ago, the 0 and the 4, so let me write that down as my x-intercepts. So I've got 0, 0. Again, this is also called roots, zeros, x-intercepts, solutions, whatever you want to call it. I knew my axis symmetry had to be halfway between these 2 points. So my axis symmetry I already knew had to be at x equals 2. Now, of course, that I've got the vertex, I can clearly see that. But you could have known that just by knowing that here's my 2 zeros, here's my 2 x-intercepts. My axis of symmetry has to be directly in between them. So just getting a few more points on here. Let's go ahead and look at the table. 2, 4. Okay, so there's my vertex. Now here's 3, 3 and 4, 0. 3, 3, 4, 0, which means that there's going to be a 1, 3 and a 0, 0. Okay, so 1, 3. So something like that. Okay, so there's that one, and how long has it been? It's been about 20 minutes. So I think I'm going to end there. Actually, I'm just going to do this one very quickly without typing anything into the calculator, just so you can see again how quick it could be. Direction, it's going to be concave up because it's not negative. If it's facing upward, that means there's going to be a lowest point or a minimum. Don't know the vertex because this is not in vertex form. It's in factored form. There's factors here. Axis of symmetry, well, let me go ahead and just start by getting my two zeros first. So x plus 3 equals 0. That means x equals negative 3. There's one of my zeros. Then x minus 1 equals 0. That means x equals positive 1. There's my other zero. So negative 3 and positive 1. Negative 3, positive 1. That tells me that my axis of symmetry, or let me go ahead and put these down here. Negative 3, 0 for my solutions, and 1, 0. My axis of symmetry passes right through the middle, which is at negative 1, which means that on my vertex, I'm going to have a negative 1 x coordinate, but I don't know the y coordinate yet. So I could even make this out. Negative 1, negative, let's go 2, negative 3, 0, 1. I could even figure out just my x's for that. And then I'd plug my function into the calculator and fill out the rest of the table and graph my function. Alright guys, well, if you have any more questions, make sure you come to class and ask, or tutoring and ask, and I would be happy to answer those for you. Thanks for watching.